Your whole group, you all agree?
Oh.
We have some debating ones. Okay. Here we go. It's a chapel day, so I'm not going to get people over to the webcam with their work. Sometimes that's a thing, but we're going fast. So, just whole class shout it out. How do I get an x-intercept?
Plug in.
Yes, factor, but why factoring? Because we're setting?
Equal to 0.
What?
Y.
Good. Use descriptor words. So, setting y equal to 0, and I heard factoring, so I'm pulling out a GCF. We're all good? Cool. It's a nice easy one because there's no leading coefficient, true?
Yes.
So all we have to do is realize that in order to multiply to be negative 21, add to be negative 4, we need a negative 7 and 3. Good, good, good? So then when we are looking for our x-intercepts, we have our leading factor of x, and then we have an x minus 7 and an x plus 3. So why, oh why, are my x-intercepts 0, positive 7, and negative 3? Which would be there-ish. 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 What happened to my sign? Oh, that's just something I memorized. It's opposite, just always remember it, right? How does it work? Yeah. Because if you had something gross like a leading coefficient and you had 2x minus 7 and 5x plus 3, you couldn't just take the negative 3 and the positive 7. You'd have to actually set it equal to 0 and solve. These ones, we call them linear factors, are easy. Because it ends up being the opposite sign, but there was math behind it, right? Because in order to multiply to be 0, what's the only way you can multiply and get an answer of 0?
0.
There had to be a 0. Where? I don't know. There or there or there. Boom, boom, boom. Good?
Yes.
Cool. We had another intercept to be looking for, right?
Y-intercept.
How do we find a y-intercept?
Plug in 0 for x.
Oh man, it's the hard one. Y equals 0 cubed. Look at all this math we have to do. 0 squared minus 20. Just kidding. It's all what?
0.
Oh, we already have it. So when I gave you guys an extra challenge and said, hey, when you're bored, why don't you sketch him? Why would this have not been enough?
Because you have to actually draw the 10B.
Yeah, how do you visit it like a zoop visitors? Swoop visitors. How could you have figured it out?
The symmetry.
Ooh. You could have tried to find symmetry. Guess what? It has none. Ooh, yeah.
Chart in the front of the book.
You could. I'm not sure that would be like straight to the perfect answer. It might give you an idea. Because this is actually a cubic polynomial, right? Why? Because it's cubed. The highest degree is 3. Don't worry, all things will review. But it's a cubic polynomial, and it has a leading coefficient that is positive, which means it's a cubic-y guy that's going always up, which could be like a that, or it could be like a that. Why does this one make more sense?
Because there's a dot.
Yeah. So it's going to have to come up and then through and then up again. How do we know actually where it goes? We're going to estimate, but what point would you guys want to plug in between negative 3 and 0? My amazing ones are like, wait, I want it to be symmetric, and I'm guessing that it's probably symmetric, so I go halfway in between. So yeah, negative 1.5 would be awesome, unless you're like, I have to do that math. So maybe just, party poopers, if you had your calculator, you could just get the sketch. How about negative 1 just to be easy and we'll be approximate? Is that okay?
Thank you.
Mm-hmm. And if we go between 0 and 7, 3.5.
4.
Okay. So we're going to throw in negative 1, we're going to throw in 4, and we're going to estimate. Any mental mathers out there? What's negative 1 cubed minus 4 times negative 1 squared minus 21 times negative 1? Okay, fine. What's negative 1 cubed, negative 1, minus 4, because that's a positive, negative 5, plus 21, so negative times a negative 1. Negative 5 plus 21? 16. Don't worry, you don't all have to be mental mathers yet. How about 4?
Oh, that's too much.
Oh, come on. 4 cubed is 64 minus 4 times 16 is 64 because it's 4 times 4 times 4.
So those cancel.
And then minus 21. You guys can do like column multiplication in your heads because you're cool like that, right? does when I say
So it's negative.
So negative 84.
That's a nice number.
Well, you know, maybe we'll scale our graph. What do you want to go by? Tick marks? Hey, don't worry. This is an entire lesson coming in like 2 chapters. How to take really gross polynomials and get really good sketches of them. And the factoring gets way more exciting. But you're welcome. Some of you are scared. Let's go by tens. That's funny. Okay, so not so much. 10, 20, 30, 40, 50, 60, 70, 80. 4. What was it? 4. Oh, I forgot where we are.
4.
There we go. So swoop, there it is. Swoop, swoop, there it is, approximately. You're welcome. Okay, are we good?
Yes.
Okay. Do intercepts get us the entire graph? Yes or no? No, but do they get us partway there?
Yes.
Uh-huh. What's another clue? Symmetry.
Mm.
Which, Jaden, it was great. You were like, hey, it's a clue. I bet it, but it didn't.
Gotcha.
If you think about the graph, it doesn't fold this way or this way or this way. Symmetry. If you were in an elementary science classroom and your teacher was trying to teach you the idea of symmetry, what animal would they almost always use?
Starfish.
Could they
I was
use
thinking
any
butterfly
other-
for the simplicity, but maybe you were in an upper elementary classroom. Okay. Starfish. That's good too. But starfish is always kind of legal, and then it's not exactly perfect.
Patrick.
What? Well, yeah, I thought about that too. But you know, usually it works. They wouldn't show you the broken butterfly example. Unless they had some weird agenda. And we'll actually sort. Can I just show you guys quick sketches and quick examples of functions? I'm going to zoom in on this page, not that. This page. Okay. A butterfly is symmetric about its body, assuming it has perfect wings. True?
Yes.
So, if a graph displays, or I should say a function, we haven't talked about functions yet. An equation displays x-axis symmetry. It's symmetric about what?
The
X-axis.
Yeah, go team. Ooh, you guys are honors. Can you answer this? What's a problem? The problem I had to remedy, besides us not talking about functions, but for me to make this example, why did I have to change the vocab to be an equation instead of a function to show you x-axis symmetry?
Can you repeat the question?
Why did I have to change from talking about functions to equations to show you something that displays x-axis symmetry?
Because a function is
A function is y equals.
You're plugging in negative for the y.
And why is that a problem? If I go to some arbitrary x, let's pretend he's a positive. And some arbitrary y, let's pretend he's in the first quadrant, kind of section 1-1, let's pretend he's in that point. Where would this point be relative to that point if this is in the first quadrant? Where would he be?
Below.
Straight below. And why is that a problem when talking about functions?
because you can have 2 points.
Functions always pass what test?
The
Vertical line test.
Vertical
Vertical
line
line
test.
can't hit more than one. But to have x-axis symmetry by definition, isn't it going to fail all over the place?
Yes.
So he wasn't allowed to be a function. He has to be an equation. Let me show you the example. Equation. Boop, boop. Which does tie in with the person who said y is by itself. Now, to have x-axis symmetry, this test point has to be the same. Here's my quick test for symmetry. Once we talk about function notation f of x, it's going to look differently. Not as in the graph, but as in the algebra and how to test. But for right now, to test for symmetry. Plugging in and simplifying. The test point. simplifying the test point results. Forget it. I'm going to stop the whole English making of a paragraph about it. Gets you back to the same place you started. Is that cool? I'll be a math teacher, not an English teacher today. Plugging in and simplifying the test point. What test point is that one? If a graph has an arbitrary point and displays or has x-axis symmetry, there must be a corresponding point with the opposite y value but the exact same x value. There has to be a copy on the other side. True? Mm-hmm. Okay, so y-axis symmetry, why does this test point make sense? If it has y-axis symmetry, if I have the same arbitrary point in the first quadrant, but it displays y-axis symmetry, where must be the corresponding point? In the second quadrant. And what changes? The x is now opposite, but the y is the exact same. True?
Yeah.
So these test points, could you memorize them? Could you just understand?
Yes.
Nifty. Good example could be y equals x squared. Test point. The x is the opposite, the y is the same. Now these can't be the exact same point, but they are corresponding points. So if you have a point here, he has to have a match opposite the y-axis. And to get opposite the y-axis, you have to flip the x. Origin symmetry. He's the funny one.
Here's a
Sure. If you have first quadrant, third quadrant. Maybe you got that by looking at the point. This one, in a way, has to fold across and down. Has to fold across and down. The x has to be opposite and the y has to be opposite for any given point. A good example would be y equals x cubed. Now hold on, wait. Jaden totally said a second ago that cubic function that we had symmetry, and I said no. Hope dashed. But he was cubic. I don't get it. You just wrote y equals x cubed. Don't all cubic functions have origin symmetry?
No,
Why not?
because there
That
are
one?
variables.
Yeah. What was different about the one we just looked at? I can go back.
Scary.
I mean, how much is there and how much is there is a bit different, yeah? And then the whole thing's like over that way a little bit. Could there maybe be a point to any cubic function where it is symmetric about in an origin-ish sort of way? Yeah. It could be symmetric about a point, but if this thing gets stretched or shifted around, a cubic function will only have origin symmetry when, well, starting bringing vocab you guys haven't talked about this year, but when its point of inflection is at the origin. Don't worry, not something you have to memorize or remember right now, but just a warning, some cubics are and some cubics aren't. So, if the graph on the last page was hard to find, and then these ones, the graphs made it easy to know what type of symmetry it was. If we're given some nasty function like the page before, how do we do this whole plug in simplify to see if it's the same without ever having to have gotten a graph? If you guys want, you could actually find an actual ordered pair on x equals y squared, like the point 4, 2, right? X is 4 when y is 2. 4, 2, and then you could check for -2 and see if it works, see if it's a solution from section 1, plug in, it's true. Or you could be super snazzy and not have to have a specific point and just say, hey, what happens if I plug in same x, opposite y? Awkward, if you will. Same x. You guys see how I plugged in to the y inside, not outside? What happens if I keep the x the same and make the y opposite and simplify? What's that become, guys? it becomes the exact same as what it was. True? Now, what if I took this exact same equation and I plugged in opposite x, same y? What if I did negative x equals positive y squared? Would that be the same?
No.
Because I can't simplify away the negative. I can simplify away that negative. It's great. It's the same. But if I plugged a negative in here, it'd be stuck. Even if I moved it, it would still change the equation. This test point works. This one does not. This one displays x-axis, not y-axis. But what happens in this next one if I plug in same y, opposite x? And simplify. That one didn't work, but this one would. Because, yep. A negative times negative is a positive, and so it simplifies and stays the same. If I was to test either one of these test points in this last one, they would change in some way, shape, or form. But what if I plug in a negative y and a negative x? Why is this the same? It sure doesn't look like it. Because, first of all, PEMDAS, a negative cube becomes a cube. A negative times a negative is a positive times another negative.
Negative.
So there's a negative on this side. There's a negative on that side. It's still different.
Cancel out the negatives.
How?
By little crossing thingies.
Lots of options. Divide by a negative 1, divide by a negative 1, multiply by a negative 1, multiply by a negative 1, or my personal favorite, add the y and add the x cubed. Either way, you get same. That's the algebraic way. Do pictures work? I can fold it. I can fold it. I can fold it. Yeah? But could some pictures be hard? So isn't it nice to have a plug-in way instead? So what if I was to give you this guy? I want you to test all three symmetries and show me either why it's a yes or why it's a no from plugging in. All three symmetries, just so we're all organized the same way. Testing for x-axis first, just because it came first in the books. Then y-axis. You might have other ways of doing this one. Not including your calculator. I want you to make sure the plugging in makes sense. Make sure the plugging in makes sense for the harder problems that are coming. Maybe now, maybe later. Maybe now and later. My brain's way of remembering which point is which. The y is opposite, the x is opposite, the x and y are opposite. Just my brain's way of doing it. Some of you might just need to memorize. Who's the same?
The y-axis.
Because what happens when you do when you simplify a negative times a negative? So is this a solution?
Yes.
Yeah. So since it's a solution, yeah, has y-axis. Anything else?
No.
Why not?
because they're not the same.
What do you mean? I was able to move the negative. Look.
But the x is still negative.
So either there's a negative there that's not the same, or there's a negative there that's not the same, not inside the parentheses, so I can't simplify it away. If you're curious what I did, either I added the y and subtracted the x squared, added the 4, or I multiplied both sides by a negative. But either way, not the same.
Not the problem.
And isn't this the same problem?
He's also.
However, just curious, who visualized the graph first and knew the answer from the beginning? I had 3 pre-calers. Where are my honors kids at? Was I too explicit with my direction? You guys are too obedient? Isn't this a parabola? It's been shifted?
4 down.
So couldn't you have thought about it? And then like, oh, I know which one. Now, once again, why am I showing you these tests if maybe you could have graphed it and thought about it a lot faster? What's coming? Harder stuff. Where the visualizing of the graphs might not be quite so straightforward. Remember this guy? Remember that guy? Okay. I think it's the last thing.
Circles.
Circles. Oh, circles, man, don't you guys learn those in like algebra 1? X squared plus y squared is r squared. How is this harder
Y
though?
r squared.
Doesn't necessarily mean that a fact is harder just because it's pre-calc. It does have an HK though. Anybody remember what the HK stands for?
It's a
A horizontal shift, a vertical shift, possibly, unless it's just -0, -0. But I have room for shifting, and if there's room for shifting, that means the center might not be 0, 0. And the radius might be a little more complicated to find than just counting tick marks on the X or the Y. So what if we have a center way out here with a random radius here? If we know the center and if we know the radius, it's no big deal, right? Just throw it into the equation. We have the equation, no big deal. Just pull out the center, pull out the radius, and get a graph. So how might homework make this hard?
By not giving us one of the points.
It might not give us the center. It might not give us the radius. Now wait a minute, can it not give us everything, or does it have to give us something?
It has to give us something.
Okay, it has to give us something, but does it have to give us the center or the radius?
No.
So what if it gives you something like this? Oh, this one's not that bad. It gives you the center. Okay, that's cool. Where would we plug that in?
In the H and K area.
Okay, so if I plug in the point -1, 2, how will my equation look? X
X plus 1.
plus 1, because it's minus a -1. We good?
Plus y minus 2.
Quantity squared plus y minus 2 quantity squared equals?
Radius, which we don't have.
Yeah.
Wait, can't we just plug in the X and the Y?
For the radius?
No.
Not for
No.
the radius,
Plug in
just
the
for
X
the X and the
from
Y.
other
We just put in the
point
3 and the 4.
to find the radius.
Oh, I suppose we could be snazzy like that. I mean, make that your unknown and then go ahead and plug in and solve?
Yeah.
Yes.
You could. Couldn't you
Sounds
also be
very
snazzy
reassuring.
and make a little Pythagorean theorem and say, oh, no big deal, I just need to go over, awkward, 4, and go up 2? 16 and 4 is 20, square root of 20 is, I don't need the square root of 20. I just need to do the square root of 20 squared. Or you could be snazzy. You could have gotten r is equal to 2 root 5. And then squared 2 root 5 to be 4 times 5, which is 20. That could have been a little rough with the distance formula. But it would have worked. But good thinking, good creative thinking, and plugging in the 0.34. So can I show you one other type of how they can make it even harder?
Yeah.
This one they gave you the center, but they didn't give you the radius, but you had enough information with the distance formula, Pythagorean theorem, plugging in the other point. So what about if we give you this? EQN, we good equation? Go.
So never say that's good.
What did I give you this one?
The diameter.
The diameter, the endpoints of the diameter. If anybody's done homework yet, you're like, oh, that was a thing.
That was kind of hard.
What are you missing?
The center thingy.
Missing the radius, and I'm also missing.
The center point.
Ugh. How do I get the center point? Midpoint.
Water body.
The center is the same thing as the midpoint of the diameter, right?
Midpoint formula.
Look at them making you go back to section 1.1. But do you remember my way of remembering the midpoint? Average the x's, average the y's. It's not a big deal. Once you average the x's, average the y's, isn't it basically the last problem we just did?
Yeah.
Where you can use the distance formula or Pythagorean theorem, or the cool plug-in. Wait, why didn't we just plug in 2 x's, 2 y's to begin with?
Because one of them has to be the center.
This must be the center. I can't just use 2. Well, I guess you could have plugged in one xy here and then plugged in the other xy and then had a system of equations that you solve for h and k and
Too
r.
much.
Oh wait, you're missing h and k and r. Wouldn't you have to set up 3 equations with 3 unknowns? I think my way's better. Questions? Did you guys find your midpoint yet?
Yes.
Average the x's. 8 plus negative 2 is 6. 6 cut in half.
3.
Average the y's. 6 plus negative 2 is 4 cut in half.
2.
Okay. So if I know this is 3, 2,
Plug it in.
Pythagorean theorem to figure out what the hypotenuse is, or distance formula, x2 minus x1 squared plus y2 minus y1 squared square rooted. Or pick him or pick him, whichever one you like better. I would probably do 8, 6 and solve for him. I think we have strategies for the hard ones from homework, but we'll see tomorrow how you do on the odds. You check tonight. On the evens, check with me tomorrow. And on the ones you get stuck, all I need to see in Google Classroom is that you tried it. Bye.
I got my left one here.
If you guys have questions, you know where to find me.